I'll start. So first of all, thank you for your invitation to be here and do my presentation. So I work with in. I will talk to you about my experience and my expertise in structural usage as a researcher and as a consultant. So I work with CERC, and we in CERC, CERC is the Innovation and Research Forest Center in Portugal. We work with innovation and development in wood products and wood-based products, but also we provide services to support wood construction. My presentation will be based on my expertise with the services and mistakes that industry does, and some good examples also that industry does in wood construction. So CERC was founded by three institutions: the Municipality of Sertã, University of Coimbra, and the Laboratório Nacional de Engenharia Civil, which is the National Laboratory for Civil Engineering. So timber structures are not new, as you may know, and are in the pre-industrial era. They were located all over the world. I'll show you here three examples of timber structures located in three different areas. The first one it was found that they were built in 4000 before Christ, and it was made by Danube people. The next one, okay, yeah. The next one was built by American native people. And here you can see a structure with 120 meters long and 10 meters height, which is not a simple engineered system. It was a quite complex. And also in China, we also have bridges and towers made of wood. Here we have a bridge with 42 meters long and 5 meters high. So it was all of these examples was from pre-industrial era, but in the industrial era, with the development and commercialization of other materials such as concrete, bricks, steel, aluminum, plastics, etc., the wood usage started to decrease until 19 until the 19th century, where the glulam were invented. Here you can see, and after that with panels and with mass timber systems. And since the development of concrete, brick, and steel, wood was mainly used for support those industries. For example, in America, wooden bridges was used to support the extraction of steel and concrete in the America land. But here I will show you some examples of glulam and CLT, mass timber systems, for you to know what these products are. Glulam assists in gluing of soundwood boards of wood. So, and when it was invented, it made it possible to increase the maximum building spans. The diversity of shapes of the soundwood beams, because we are not more limited to the dimensions of 3, and we can glue more soundwood boards to increase the span and the length. We also can reduce the defects in wood and improvement in structural behavior of wood products. Here in Portugal, I will show you two examples. One of them is the Altice Arena. For those from Portugal, I think that they may know the Altice Arena, but they don't know that they have a complex glulam structural system where we have a total of 17 transverse arches with a span of 114 meters length. So this is a picture of the interior of the Altice Arena. Here is a more recent one where we have a bridge with a span of 120 meters, which is a bridge made of glulam It was built for the Jornadas Mundiais da Juventude, which was I don't know the correct translation, but it was built last year. Here is the structural system and photos during the construction of bridge. The other material that I'd like to present you is the cross-laminated timber, which consists of gluing of soundwood boards, but transverse in a transverse way. So we have boards in one direction, and in the other layer we have the boards glued in the other direction. So it made it possible to obtain panels with greater dimensional stability. The weak and also we have a structural material with a behavior of a shell, which it is possible to use this material as walls, floors, and roofs. We can also increase the level of prefabrication and building and increase the thermal comfort and energy efficiency of building. So here you have one example of a building made of CLT. It was a system that combined CLT with glulam and with concrete, but this is the first high-rise timber construction. I think that most of us may have heard of them, of these buildings, but it have 18 stories high. So it was a good innovative building for timber construction, and it's a good example. Here you have the example of a CLT-based construction, a building. Now I will show you, after the presentation, I will give you some advantages and disadvantages and challenges that from my experience I can identify in the wood construction and the wood transforming in industry. I will start by advantages. Main advantage that identifies this sustainability, the wood products during the growth of trees. The trees have the power to capture carbon dioxide and keep them into wood. So when we use wood products, we are also using carbon dioxide that is sequestered inside wood. This is a good advantage when we compare wood with concrete and with steel, because we have a low carbon footprint. Next one is the cascade usage. What this means that in the end of life of wood products, we can have another use for these products. For example, in the end of life of a soundwood board as a structural product, we can mill these wood and use them as raw material, as a raw material for panels production. And then we can, and so on. And in the end of life, we can at least use wood to produce energy. So this is a good advantage of wood, and we can increase the life cycle of wood products. And the last two, I will talk about them in just one slide. It is the speed of construction and the modularity with prefabrication. So nowadays we are facing problems with lack of human resources for construction, and we need to increase the prefabrication of this of our buildings, and wood allows that prefabrications. And we can also reduce the time for construction. For example, we work here in CERC with companies that since they build the land until they give the owner the keys of the house, they take four months to build all the house. So it's a very good time. Now I will talk to you about some disadvantages. I don't like to call it disadvantages. It's more challenges that we are trying to face and trying to improve. The first of one is the lack of material, and the sustainability of wood and of wood forests need to have one basis and one column to support all the sustainability. Which is when you cut a tree to use in construction, we need to plant another tree to ensure that we are continue having raw materials for our system. So it is important for us to ensure that we are building and we are using raw materials from FSC and PAFC systems in our construction to ensure that the timber comes from sustainable forests and from sustainable systems that plant another tree for a tree that we are using. Another one is the price. Per construction is not very good in terms of price because in the last years at least here in Portugal, we are facing an increase of prices. Here in this graph, you can see the increase of price in the last years due to the lack of raw materials. But I think that, and we here in SEC, we are doing research about that. We are trying to reduce the price by improving the cascading use of wood, which means that if we can optimize the use of wood, and we use wood as a structural material and has a different material with good characteristics, we can in the first usage use it as a good material and as a structural product, but in the second usage, in the end of the first usage, we can use it as a constructive product for thermal or acoustic installations. And another challenge that this is a good one challenge is the durability. Here you have two pictures of the same bridge separated by 10 years. The first one was during the first years of usage, and the second one was 2 years ago after 10 years of use. So, but and the aspects related with durability was due to the lack of knowledge in the technical documents of construction and the lack of technical knowledge in specifications. In this case, the owner asked for a timber bridge made in. They don't specify the timber species, the wood species, but the wood species was Piscia avis. As you may know, Piscia avis is a very good wood species, but for use in the interior of houses, not in exterior, not in outdoors. But in this case, the Piscia avis start having fungus attack, and they don't see it, and then they don't see it in time, and it was the final result. So it is very important to know and to have technical knowledge when we do the specification of timber buildings to prevent this type of scenarios. And the last one, I think that is that all of us know that timber burns. It's not new, but it's new that we can prevent timber from burn. We can use sealing materials that prevent wood from burning, and also during the design stages, during the structural design stages, we can consider and take into account the fire, the behavior of wood into fire, and we can ensure the security of people that use our structures. And so it was a short presentation. I think that do you like it? If you have any questions, this is my email and my phone number. You can contact me. And once more, thank you for the invitation to share my knowledge with you.